What I'm going to show here is a demo of how the virtual laboratory is integrated with GEOS. Here we have online Guido Colangeli from the GEOS web portal development team. He's coordinating the developments of the GEOS web portal, and we have worked together in order to test the integration of the GEOS portal and the virtual laboratory. So how to run the models which are present on the VLab using the GEOS web portal and ingesting data which are available in GEOS. So once the model is inside the VLab, it is integrated with GEOS framework and GEOS platform. So this is the testing environment for the GEOS web portal integration with ECOPOTENTIAL VLab, and when you load it, you are displayed with the ecosystems which are being studied in ECOPOTENTIAL. So you have mountains, coastal marine, arid, semi-arid, and you have you can see some descriptions here. All of this is fetched from the VLab APIs, which are used by this portal in order to fetch the content. Then you can select one protected area, and you see, one ecosystem, and you are displayed with the protected areas belonging to that ecosystems. And then if you select one of the protected areas, for example, Camargue, you are displayed with available storylines, the ECOPOTENTIAL storylines which are associated with that protected area. In particular, here we have this land cover change in Camargue, and when you select the storyline, you can visualize the workflows, so the models which are associated with that storyline, so the models that implement that storyline. In this case, we discover the EODESM workflow. So Richard has just presented what EODESM does, and this is linked to the Camargue and other protected areas in ECOPOTENTIAL. When you discover the workflow, you have the description, and you can also see, let's say, a visual representation of the workflow. Here you have the inputs and the outputs which are needed and produced by the workflow. So if you want to execute this, you need to ingest inputs. So you can select which input you want to search on GEOS, for example, the clamps, and you click select resources. This sends a query to the GEOS platform in order to discover possible inputs for that specific variable. In this case, you have the clamps for Camargue. You can select it and click accept. So now the clamps input for the model has been set. You can select the other layers, again with the same procedure. You click, you select which input, you click select resources, and again a query is issued to the GEOS platform. You might want to use the different ways of searching data in GEOS. In this case, we are selecting the layers. We might want to have the layers which are available before 2010, for example. So we select the constraint and we search again, and we find this layers for the Camargue, again, which are from year 2006. We add it as input and go back here. The same for the period 2 layers, what Richard explained as before. Again, you select resources, and in this case, you might want to refine your search by discovering layers which are after, for example, okay, sorry, after 2011. And again, you can search, you find some layers for Doñana, for Camargue, because we did not set the bounding box, but we have some layers for Camargue in 2015. So again, add input and accept. So now you're all set. You have selected all the layers, all the inputs which are required by the model, and you can run. When you run, okay, let me, okay, good, okay. And then you can see, okay, here you have your run has been submitted, and the results have been saved in saved runs. So you can look at the available runs here in this different tab. And well, the EODES model takes quite a long time in order to be completed. This is, well, I have launched a couple, clicked too many times. These are the 2 runs which have just been launched. You can see the status, which is queued, and you have some logging message. So since EODESM takes 2-3 hours to complete, we have some saved outputs, and we can show here, for example, this run was completed. You can click on outputs, and you can either download the Kia file, or you can show the WMS layer on the map. So you can click here, and you are displayed with the layer. Sorry, it's slow now. Okay, there we go. Yeah, I'm recording the session, so my PC is getting very slow, but we should see the layer loading shortly. This is the output of the run with the changes and the legend which Richard was presenting in his presentation. So this is the idea. So we bring the model into the VLab, you can test, you do whatever you want, and then this is connected automatically to the GEOS platform, where users will be able to discover the model and run it using inputs which come from GEOS, which is a big global interoperability infrastructure. So this is it for this demo. Yanis,
Yes, thank you, Mathieu.
Yeah.
Maybe I don't know if there are some questions at this stage. Otherwise, you can continue with the yes, with the virtual laboratory description. Are there any questions at this stage, or can it wait until the end?
Hello, John was speaking. Can I pop a question?
Hello?
Hello, yes.
Yeah.
Hello. I have seen that there are several pre-compute line cover change and line cover maps in the system, and those are visible using what seems to be a map browser, some kind of a WMS. My question is very simple. Is this on a standard WMS? Can I get the endpoint of this WMS and explore what has been pre-compute and integrate that in some kind of other viewer?
Sorry, I'm not sure I got the question right. So we are talking about the output or the input for the model?
I'm talking about the output. You showed not in this last presentation, but in the previous one, that the output of an execution of the EODESM is actually shown in a map browser.
Yeah.
And some of them are pre-compute, if I understood correctly. So my question is that map browser, or is there a service, a standard WMS service behind this map browser that we could use to see the pre-compute things?
Yes.
I can answer that as well, Matthew, if you would like me to do that.
Yes, I mean, the point is that the EODESM produces two outputs. One is the data file, so the KIA file that you can download, of course, and the other one is the rendering of that KIA file as a standard WMS. So you interacting with the VLab APIs, you fetch the URL of that WMS, and you can request for the map which has been produced. Does this answer your question, John?
Yeah, I was wondering if the pre-compute executions are available. So
yes, absolutely.
if I can,
yes.
So can I get the URL of the endpoint of this service?
Yes, you
the
can.
Service that shows the map?
Yes, absolutely.
Okay, great. Can you send it to me?
For sure.
Because I'm curious for it.
Okay. Okay.
Mathieu, can I share the screen very, very quickly just to convey that?
Yes, Yanis, can you give? Okay, great. Thank you.
Okay. So basically, when you download your KIA file, and if you can't read it, we'll send you the instructions. It's basically on a Unix, but you won't have to wait long, I don't think, to be able to download as a shapefile. But basically, behind every object, you have a whole data set here. Okay, so we can look at things, and it gives you all the information on the environmental variables. It gives you the classification. It gives you the individual codes. You can see these. This is natural, terrestrial, vegetated, for example, and so on, natural water. It then combines all the codes, and you can then have your LCSS description. This happens to be period 2, but then you can do period 1 and so on. Then you have all the change information. So, but what we can do is then, if you want to download water depth or water sediment loads, the idea behind the virtual lab will be you'll be able to select what you want to download or access to the web map server. So that will certainly be coming, and it makes it a lot easier to handle and understand the layers. Okay, thanks, Matthew.
Okay.
There is also another way of integration that comes to my mind, and this is that somehow in the virtual laboratory we are able to preview the inputs. And I believe we have to sit together and see how we can better integrate the virtual lab with this map browser. This map browser that exposes the all inputs that the ELSM is using, and this will give us a more visual result, I believe. So let's think about that and let's see how we can sit together sometime and make progress on this.
Okay, thank you, John. Yanis, am I presenter? No, not yet.
No, but I think Richard has to give you this right. I can't. I'm not the organizer for this session.
I can maybe assign it to myself. Yeah, I did it myself. Okay. Okay, so now I'm giving a brief introduction of the VLab platform. I want to thank Richard. This presentation, which I'm showing now, was scheduled to be first, but Richard is in Australia at the moment, so we moved him at the beginning because there it's very, very late. So thank you again, Richard, for joining this webinar.